Hmm. So you said that it's like a linear growth?
No, it's not. Not like linear.
Yeah. Yes, it is not linear because you will see that the variable x will be in the exponent. Okay, but first we need to understand the meaning of exponential growth. Okay, so the exponential growth happens when something is compounding. Let's just say that you have $100 with you. You have $100 and you go to a bank and you deposit your money with them. Okay, so the bank is gonna pay you 10% interest on this. Okay, for let's say 5 years. Okay, then at the end of 5 years, what is the amount that you will receive? So what is happening here is now so there is a formula for finding out this answer, but I want to explain you what's happening behind the scene. So the bank takes your $100. Okay, then every year they are applying 10% interest, right? So you will keep getting 10% of your amount every year. Okay, so 10% first year. So Anika, in at the end of first year, how much money will be there in your account?
Would it be 110?
Yes, 110 at the end of the first year. Then what will happen? Now you will get interest on this 110. So now 110, and now again you will get 10% interest. So what will be the amount at the end of second year?
121?
Wow, that's great. Yes, so 121, and this process will continue like this. So then you will get the interest on $121, again 10%. So at the end of third year, so this will continue like this for 5 years. Okay, then at the end of 5 years, the amount that you will have, that formula is given by, you keep continuing like this. So your amount it is equal to a times 1 plus r raised to x. Now let's see what is a, what is r, what is x. The a is the initial amount that you deposited, so the $100. Okay, so that's initial amount. R is the rate of interest that you're getting, the 10% rate of interest, and x is the time period. You must have seen this formula, right?
Yes.
Compound interest, right?
Yes.
So the answer is going to be, if you substitute these values, so you'll write 100 times 1 plus r needs to be converted into decimal. Okay, so
Okay.
10%, so you will convert it into decimal and you'll write 10 over 100 or 0 0.1, and this raised to 5. So this is your exponential growth, Anika. This is the question of, I mean, this is the case of growth.
Okay.
Pretty easy, right?
Yes.
Okay. Okay. Now, similarly, you have the case of exponential decay. Okay. Now, there is one more thing that you should know. You could be given either you could be given your numbers like this, that this was the initial amount, then this is the rate of interest, then you have to find out the amount, or you could be given some data, Anika. For example, if you have this data, 50, 100, 200, 400, 800, 1600. These are some values, and you have to write the exponential equation, the equation of the function. Or maybe you have to find out what will be this value. So let's say these values are y, and x values are 0, 1, 2, 3, 4, 5, and we have to find out what will be the value of y when x is equal to 100, let's say.
So would you plug it into the formula, or
Which
could, well,
formula?
like, the compound interest formula, or would this
Compound
be something?
interest, okay. Yes, so can you tell me what will be the formula in this case? So the formula was y is equal to a
To
times,
a times 1 plus r to the power of x.
hmm, what is you need to find out x will be a variable, y will be a variable. What is a and what is r?
So r would be,
So if you think about it, this is like giving you the values of 100. If these values were given like this: 100, 110, 121, right? And the rate,
mhm.
and the rate is not given. So this problem is exactly like this. Here the the amount is given to you like after every year, every 1 year, but the rate is not given. So can you write out this equation?
Um, so how would you find the rate? Or can you not?
Yes, how can we find out the rate? So for that you need to check how the values are increasing. mm, from 50 to 100, what is happening? From 100 to 200, what is happening? Like that.
It's doubling.
They are getting double, exactly. So times 2 times 2 times 2, right?
Mhm.
So can you find out the rate in percentages? Is it possible? From 50 to 100, how much is the percentage increase?
Well, this,
So if you have to find out the percentage change, if you have 50 and you have 100, how do we find out the percentage change?
well, I know 50 times 2 equals 100.
No, how do you find out the percentage change if you have two values? Let's say you have these two values and you have to find out what is the percent change that has happened. So you do the final value minus the initial value divided by the initial value
So the
times,
100 minus
hmm,
50 divided by 50.
yes, times 100.
So 50 divided 100.
100. So the change has happened 100%. The rate is 100%. So, and if you think about it, you started with 50, and when 50 became 100, that means you are getting exactly 50. You deposited 50 and you're getting exact 50. So that means you're getting 100% interest. Then from 100 to 200, you're getting 100. So that is again 100% interest. From 200 to 400. So whenever the amount is doubling, then you're getting 100% interest. So the formula here will be, this one will be y is equal to a is what, Anika?
The initial amount is 50, I think.
50. So 1 plus, and rate is 100% raised to x. So y is equal to 50 times 1 plus 100% is 100 over 100, which is just 1. So this is y is equal to 50 times 1 plus 1 is 2. So this will be the equation.
Okay.
And other way of finding out the equation, Anika, is one way is this, that you find out the percentage change. You can find out the percentage change between the two values. The other way is that you can identify from here. See, your 100 is equal to 50 times 2, right?
Right.
Your 200 is equal to 50 times 2 times 2. Can we write that?
Yes.
400 is equal to 50 times.
2 times 2 times 2.
Exactly. Now if we see the pattern, so the pattern is here, this is 50 times 2 raised to 1, this is 50 times 2 raised to 2, this is 50 times 2 raised to 3, right?
Right.
So, and if you continue like this, your equation will become, so see, this value 100 you got when x was 1, so this is when x was 1. 200 you got when x was 2. 400 you got when x was 3. So what will you get when x is just x?
So x is
Y is equal to 50 times 2 raised to x. When x is 3, then it's 2 raised to 3. When x is 2, it is 2 raised to 2. So when x is just x, so it is going to be y is equal to 50 times 2 raised to x.
okay.
And that is exactly what we got by doing the percentage change, 50 times 2 raised to x, right? You can compare the two answers. 50 times 2 raised to x.
Yes.
Okay, so these are the two ways that you can find out the equation. Okay, now the next one is, Anika, it's exponential decay. Now in decay, what happens is the values will keep on decreasing. it, we can understand by the name exponential decay. Exponential decay. Can you think of an example of exponential decay? Like
Um,
for growth, we had the compound interest example.
decay. Um, like bacteria.
Bacteria. Okay, yes, there could be some bacteria that is just decreasing. And now I'll write some data. So would you try to write the equation if I give you the data?
Okay.
Okay, and then you will notice something interesting. So we have this data, Anika. Z 0, 1, 2, 3, 4, 5, and we had 2400, then 1200, then 600, then no, actually let me change the data this time. The 2400, um, okay, let me keep it same. 1200, then 600, then 300, then 150, then 75, and so on.
Okay.
Mm. And you have to write the equation, which is y is equal to a times something, let's say a times b raised to x, you have to find out the value of a and b, or this is same as y is equal to a times 1 plus r raised to x, where 1 plus r is just b.
Okay.
Now, okay, one more thing is, Anika, this time instead of 1 plus r, we get 1 minus r.
Minus r. So would y be equal to 2,400 times 0.5 to the power of x?
Yes, that's correct. Y will be equal to 2400 times 0.5 to the power of x. That is absolutely correct. Or y is equal to 2400 times 1 half raised to x. Both of them are correct. Okay. Now, Anika, whenever you see an equation of either this type or this type, now in this one you will see that this number which is raised to x, this number, if it is between 0 to 1, this number, if it is between 0 to 1, then that will be the case of exponential decay. Or if you see 1 minus r, well, it's easy to identify from this that this one is the case of decay. But if it is not written in 1 minus r form, if the number is written and if it is between 0 and 1, 0.5 is between 0 and 1, right? So just immediately understand that this is the case of decay. Okay.
Okay. Because when that situation, like, it'll never be more than 1?
Yes, if it is more than 1, like in this case you got 2, so that will be the case of growth. Okay, so I'll give
Okay.
you one result now. Okay, if your function is this, f of x is equal to a times b raised to x. Okay, now in this case there could be there are two possibilities, Anika. First case is that your b is greater than 1, this number which is raised to x, this is b which is greater than 1. Another possibility is that it is between 0 and 1. Okay, so this will be the first case, will be the case of growth, and this will be the case of decay. Okay, and you could be given a graph as well,
Okay.
so you should also know how the graph of exponential function looks like. So the graph of the growth case will look like this. It's gonna be something like this. Okay, this will be the graph for y is equal to a times b raised to x when b is greater than 1, and for decay it will be like it will fall down. Okay, this is for y is equal to a times b raised to x when b is between 0 and 1. Okay, Anika,
Okay.
which is what is the y-intercept. Okay, now you should know how to find out the y-intercept in two cases. First case if the graph is given, and second case if the equation is given. So when the graph
Okay.
is given, it's very easy. So can you guess what is the y-intercept of this graph?
the y-intercept of this graph will be oh wait,
Y-intercept is that point at
well,
which
wouldn't it just be -5?
0 comma negative
0
5.
point -5.
Yes, so option B is correct. So it is going to be that point at which the graph crosses the y-axis. Okay, so this point. Now same thing, we should be able to find out if the equation is given, okay. And in this one I have seen that lot of students make a mistake. So if you have this equation, Anika, y is equal to um, 27 times 8 raised to x plus 3. This is the equation, okay. You could also have a plus 3. Plus 3 means that it has shifted up by 2 units. Now if you have to find out the y-intercept and this equation is given, can you guess what it would be?
Then wouldn't I just plug in like 0 for x and so?
Exactly, you will. The correct way is that you plug in x is equal to 0, but most of the students make this mistake that they say that the y-intercept would be just 3, because they they compare this equation with the linear equation y is equal to mx plus b, and sometimes it becomes confusing that here this b value is the y-intercept, right?
Hmm.
But it's not the case with the exponential functions, okay. So here you
Okay.
might think that this 3 value is the y-intercept, but no. The correct way is you put x is equal to 0. Here when we put x is equal to 0, then we get b. But here when you put x is equal to 0, then you'll not get 3. So can you tell me what will be the y-intercept for this case, Anika, for the exponential function?
For an exponential, so 8
It's
times.
this one.
Okay, so 127, 30?
30, yes, perfect. So it is going to be sum of this value and this value always.
Okay,
Because when you put x is equal to 0, then this term becomes 1
1.
always. So it is always going to be the sum of this 27 and the constant term. Okay, I want to discuss some different types of questions that we haven't done yet. I think I'll leave this one to you. You could try this out. Mm, difficult. Let's try this one, Anika.
Okay.
Or let me see if there is a question type that for which I'm not taught you the concept. X, you can do this, you can do this. You should be able to do this. This is slightly tricky. I think you should be able to do everything with whatever we have done so far. Okay, then let's do one practice question. Let's do, where is it? Yeah, this one. So here,
Okay.
as you can see, some data is given, right? So the x values, you can say that these are the x values and these are the y values. X values represent the number of the day, and the y values represent population of some bacteria, right? And they've given that this population is growing at an exponential rate. Then on which day the number of bacteria per milliliter will reach this amount. So that means, so this is 1 2 3, and then at some point this population is gonna become 5.12. times 10 raised to 8. We have to find out that on which day, right? That means we have to find out the x value for which the y value become this. So y is equal to a times b raised to x. We have to find out that if y becomes 5.12 times 10 raised to 8, then this will happen for which value of x? So first thing, Anika, you need to figure out what's a and what's b.
Um,
You can also first write it like this: y is equal to a times 1 plus r raised to x. First thing, Anika, can you tell me what's the value of a?
5.12, 5.12.
No, a. I'm asking about a.
And
A was what?
I thought it was 5.12. Or is that the wrong equation?
What was a, Anika? Like, when we did the
Oh, the initial value.
initial
Initial
value,
value.
yes. So a is what?
2.5.
This whole thing, 2.5
Oh,
times 10 raised to 5, that's the initial value, times 1 plus r raised to x. I hope this is clear that you have to find out at which day. It could be number 4, like it could be 5, it could be 10. So on which day the population will become this much, right?
right.
So how can you find out the value of r if the data is given? How do we find out the rate, the percentage change, Anika? So from this to this, what's the percentage change? So if you have
Maybe
to
2 times 2? Well, I
sorry,
don't know actually.
sorry, can you say that again?
Well, would it be by 2? Like the. Well, wait. So
uh,
it looks like each y value is changing by
hmm.
like times 2 is being doubled.
Yes,
So would that mean
that
that
is correct. So it is getting 2 times. This one has also become 2 times.
yes. So does
So
that
what will be the equation?
would it be would the ratio be 100%?
Yes, 100%. And
So
if you're able to identify this 2, then you don't need to go to the percentage. You can just
oh,
put
okay. So then I can just plug in 2.
b. Yeah, you can plug b is equal to 2.
Okay. So 2 point. So
Why?
ratio is 2.
What will be the equation? First, let's write down the equation.
So 2.5 times 10 to the fifth power
Hmm.
times 2 to the power of x.
Okay, now I'll remove all of this. Let me write it here. So y is equal to 2.5 times 10 raised to 5 times 2 raised to x. Now this is the equation of the exponential function. Now we have to find out for what value of x we will get this value of y. So instead of y, I'm writing 5.12 times 10 raised to 8 is equal to 2.5 times 10 raised to 5 times 2 raised to x. Now we need to solve this equation, Anika. So can you try to solve this? Can you tell me the first step? Try to isolate x.
Well, isolate x. Um, so like
Hmm. First, you try to get rid of this number. We can divide the equation by this.
On both sides.
Mm-hmm. Then only
So
you will get rid of this, right? If you divide the entire equation by that
right.
number. So this,
So then
right here as well, I'm dividing by this, so that will get cancelled, right?
right.
So what will be
So
this?
um will I end up subtracting the denominator from the numerator? Or
For the exponents, for this one and this one,
so 5.2 divided by 2.5 is
5.12.
yeah,
Hmm.
is equal to 2.048
Okay.
2.048 times 10 to the
2.048 times.
10 to the power of 3 is equal to 2 to the power of x.
Okay. So this is your what? This is one equation. This is called exponential equation. Do you know how to solve exponential equation where this x is in exponents?
Um, do I have to like use logs?
No, in this case you won't need to use the log. So Anika, wherever you see, and in SAT math you will never need to use log. Uh,
Okay.
okay, so in always try to think like this, that every question there is always a smarter way to
Could I
solve
use
every question.
Desmos or
You
no?
can you can use Desmos, but again, every question on SAD math can be done using, just if you think critically. So first of all, you should know, Anika, that if you get any exponential equation, how do we solve it? You need to make the bases same on both the sides. Like here you have 2 raised to
But
x.
on the other side, I have 10. Well, 2.048 times 10 as a base.
Well,
Or,
you need to make this entire thing in powers of 2, like 2 raised to something, and this will be equal to 2 raised to x, and then we whatever this will be, that will be the value of x. Okay,
okay. Okay.
so we need to do that. So first of all, let's get rid of this 10 raised to 3. I don't like this 10 raised to 3. So what will you get if you multiply 2.048 by 10 raised to 3? 10 raised to
Uh,
3 is 1000.
so 2000, and 2048.
Yes, 2048 is equal to 2 raised to x. Now, can you write 2048 as powers of 2?
I think so.
Hmm.
Um, yes, you can.
So here you can try to use your calculator. Try to plug in random numbers. Wait. Now, I know one thing. I think you should also know this, Anika. You should know this, that 2 raised to 10 is
1000 and something. So it can only be 11.
2 raised to 10 is 1024.
So it would have to be 11.
11. Yes, so this number, so I can write basically, I can write this number as 2 times 1024, and then 2 times, this is 2 raised to 10, this is 2 raised to 11, so that is equal to 2 raised to x. So what is the value of x?
So the value of x will be equal to 11.
11.
So day 11.